Hey everybody, hope everybody's doing okay. Well, on this video, which is where I try to divide into the brain into 4 different parts, this is the 3rd part, and I'm going to clump together the meninges of the brain and the CSF circulation. Okay, so we'll go over the meninges of the brain first. Okay, the meninges of the brain. We went over the meninges of the spinal cord, which are connective tissues that surround the spinal cord. There's going to be alternating spaces in meninges. It helps cushion the spinal cord and protect it. Same thing happens with the brain. Let's start off with the meninges of the brain. Here's the skull. This is the scalp, where your hair comes off of. Skull. Here's the cerebrum. Okay, this is particularly the cortex. All right. All right, so let's go over some of these structures, meninges and spaces. Okay, so the cortex, the pia mater, the arachnoid mater, and the dura mater. Now, the dura mater in the around the brain is actually twofold. It's the meningeal layer and the endosteal layer. Okay, and in between the 2 dura maters, here you have this big cavity. That's called the dural sinus. The bloodstream is going to go through in between the 2 layers of the dura of the skull. So let's do the spaces. So pia, arachnoid, and dura. This is the subarachnoid space. Here you see the little lines here. And here you have the subdural space. Now, the epidural space would pretty much not be like the spinal cord. It's pretty much just the dural sinus between the 2 dura layers. What else can we do? The CSF circulation. This thing right here is called an arachnoid granulation. I'm just going to introduce it now. Maybe I'll use this model again when I do the CSF circulation next. But the CSF is going to go from around the brain and into the bloodstream via this arachnoid granulation. And it's going to be lined by cells called astrocytes, and the astrocytes maintain the blood-brain barrier. So basically, I just wanted to show you the meningeal layers, okay, and the spaces. Oh, there's one more model, which is this one, that so kindly held up that block, right, which is going to be just mainly dura mater. Okay, all right, so the meninges is dura mater, and the dura mater is going to be hard, and it's going to separate the 2 cerebral hemispheres, the 2 cerebellar hemispheres, and it's going to be a dura mater that separates the cerebellum from the cerebrum. Okay, so let's look at those 3 dura mater that compartmentalize each one of those sections. That's it. Okay, so the first one's going to be called the Falx Cerebri, which is this one. The Falx Cerebri, you can see, it's dura mater, and you can see the superior sagittal sinus there, that blue, and the inferior sagittal sinus wedged up in between those 2 dura layers that I just mentioned earlier, the endosteal layer and the meningeal layer. Okay. So this dura mater, it's really hard, is called the Falx Cerebri. Now, this one down here, which is horizontal, kind of looks like a tent, goes up like a tent, goes up like a tent. Okay, that's called the Tentorium Cerebelli. Again, dura mater. Tentorium Cerebelli separates the cerebral hemispheres from the cerebellar hemispheres. Okay. And then finally, you can't see it here, but you'll see it in here. Let me see, let me put this together. Okay, right there. Okay. That's going to be called the Falx Cerebelli, and the Falx Cerebelli separates the 2 cerebellar halves or hemispheres. Okay. So those are our 3 dura maters that compartmentalize our cerebrum and cerebellum from each other and from within. Okay. All right, so that's it. That's all the meningeal layers. Those are the meningeal layers and spaces. All right, so let's do the CSF circulation. Within our brain, we're going to have cavities and spaces which allow the CSF to travel through it. Okay, and let me just show you a little diagram here. Here you can see our subarachnoid space and arachnoid granulation dumping the CSF into the bloodstream. Okay, so the lateral ventricles dump the CSF into the 3rd ventricle, The CSF goes through the third ventricle to the cerebral aqueduct into the fourth ventricle, and the CSF can go up and down the central canal or go around the subarachnoid space of the spinal cord and then go around the subarachnoid space of the brain, and then the blood will go out the arachnoid granulations into the bloodstream and start all over again back into the choroid plexus can produce the CSF again. Choroid plexus is lined by ependymal cells, and that's what helps produce the CSF. Okay, so that's just an overview of the cerebrospinal fluid circulation in and out of the brain and around, in and out of the spinal cord. Okay, let me just show you one last time over here. The subarachnoid space is going to contain the CSF. The CSF goes through the arachnoid granulations and dumps into the bloodstream. Okay. This model here is supposed to depict CSF. Okay. So just imagine this being like an ice cube. The water takes the shape of the tray. Same will apply here with the CSF. The CSF taking the shape of the ventricles within our brain. Okay. It kind of looks like the USS Enterprise, Star Trek. So these two up here are going to be the lateral ventricles. Okay. This here in the middle is our third ventricle. You can see it takes the shape of the diencephalon, hypothalamus, thalamus. The eye, the intermediate mass, goes through here, and the epithalamus up here. So that's the diencephalon. Because the diencephalon's two walls, a right and a left wall, and in between is cavity, and CSF is in there. And then what connects it to is the intermediate mass, like this. Okay. So the third ventricle, then the CSF will go from the third ventricle through this structure here called the Cerebral Aqueduct. Okay, and the Cerebral Aqueduct is this one. Remember I showed you here, there's the Cerebral Aqueduct, which is part of the, so the third ventricle here, Cerebral Aqueduct, or Mesencephalic Aqueduct, or Aqueduct of Sylvius. And then here we have the fourth ventricle, which will be down here, the fourth ventricle. Okay, fourth ventricle. So two lateral ventricles, third ventricle, fourth ventricle. Now you can see the little pink structures within each ventricle here, a little pink. Those are the choroid plexus, choroid plexi, okay, which produces CSF in the third, in the fourth, and the third. I don't know if you can see the pink. I don't know how I can position this. There it is, the pink in the third ventricle. And then down underneath here, you see the pink in the lateral ventricles, which are the choroid plexi, and it produces CSF. The only thing I got to mention is that the lateral ventricles connect to the third ventricle via the interventricular foramen, which are these two little connections here. That's called the interventricular foramen, or the Foramen of Monro. And then I mentioned this already, but the third ventricle connects to the fourth ventricle. Whoops, I don't know if you saw that. The third ventricle connects to the fourth ventricle via the Cerebral Aqueduct, or the Aqueduct of Sylvius, unless it's a phallic aqueduct. Okay. And then from there, the CSF will go via the one median and two lateral apertures outside the brain and into the subarachnoid space of the spinal cord, around the brain, to the arachnoid granulations, and then eventually into the superior sagittal sinus and inferior sagittal sinus of the bloodstream. And then come back and send a signal to these pink structures called the choroid plexi, and start with the lateral to the third to the fourth, and then do the circulation once again. Alright guys, that's it. That's all I have for you in this third video. If you have any questions, let me know. Make sure to like and subscribe. And I'll check you out on the next video, the final part of the brain, which will be the cranial nerves. And that one should be short. Alright, talk to you later. Have a good one. Bye.